Okay, welcome. Today's lesson is 86, volume of pyramids and cones. What's our objective, class? Get ready?
Volume of pyramids and cones.
So thank you for your attention. So what we're going to do is talk about, if I have, let's take these two shapes, a pyramid and a prism that are the same area of the base. So look at the base here, same dimensions, right? So the area of the base is exactly the same, and then the height of my pyramid and my prism is the same height. Okay, look at the height, the tip of that goes right up to the top. The question is, if I were to fill this with water, how many of these would it take to fill the prism? Okay, show me on your fingers how many you think this is going to take to fill up the big one, the prism. So 2, I see 3, 2, 2, 2, 2, 2, 2, 2. Okay, we're going to do that right now. I need a helper to hold, someone with a steady hand. We're going to flip these over. Let me go, Tate. Tate, I'm going to have you stand right here on this side, and I want Tate, so as long as you're okay to be in the video,
yeah,
you'll be famous. All right. So you're going to have you hold this over, and then you got to have one hand under here. Okay, I'm going to fill water in it. All right. So we have the little catch basin just in case we spill. I spilled kind of a lot last class. You're almost there. There's a little air vent hole on the side. You see a little bit dribbling out.
Miss Boone, you're getting the call. Someone's calling you.
I'm hitting a call. Okay, that's okay. Okay, so now what I'm going to have Tate do, you got to hold on that pyramid? I'm going to put the funnel right here and have you have to spin that around, but see the big hole right there? Dump it into this funnel.
Okay.
Make sense? I'm just putting my hand on that little vent hole. There we go. And it'll just pop right out. If you let go of the vent hole, it'll come out way faster. Woo!
Oh, sorry about that.
Yeah, you're right. Yeah, here, let it down. There you go. So we mostly, I think we lost a couple of little drips, but nothing super heavy duty. Okay, so that was one pyramid. What do you think now, would you change your vote? How many pyramids it would take to fill up the cube of the same area of base? I see 3, 3, 3, 3, 3, 2, 2. I see 6, 3, oh no, 3 and 3. Okay, let's do another one. Okay, same thing. All right, one hand holds that. Okay, and then Maddie, you can get this in the video, right? Is this in the video? Oh, it's going all down his arm. Poor guy. All right, I'm going to have to level that out just a little bit so we can fill all the airspace in there. Whoa, there we go. Yeah, we're spilling. That's okay. That's all right. Okay, I'll hold this here, and so you're gonna pour it out that hole, and then leave that unclogged. Ready? This is kind of cool. So one year I forgot to get funnels. I usually borrow them from the science room. These I bought my own, but I didn't have a funnel, and I had to pour that into the hole without a funnel, and I did. I spilled a little bit. I don't know if anyone had any last year that remembers that. Okay, so that's 2 pyramids. 2 pyramids have now filled this much. What do you think? Would you change your vote? Chelsea says 2.5, 3, 3, 2 and a little bit more. What if it was pi? That would be super cool.
Yeah, two pie.
All right, last case. We think it's the last one. We'll find out. All right, you got the funnel. I'm going to go get more water. It's going to go down your arm again, isn't it? You're getting good at this though. And then last year we had a sink and a faucet in my classroom in the old building, so it was really nice. Okay, we're pretty much full. Okay, we'll take this, transfer it to this guy. Ready? I'll put it right. It's like once you see it, I think it'll stick in your mind. You're going to see it and you won't forget the ratio. And on the rise test, if you know the right proportion and can figure out area of the base like what we did yesterday, you'll get this. Okay, so that was a complete 3, I mean, with a little bit of spillage. That is about perfect. I mean, there's a tiny bit of air in there. So that is a perfect filled rectangular prism with the same area as the pyramid that has the same base, okay? So if thank you, Tate. You did great. You are all done. All right, so this, okay, so this has, if it took 3 of these to fill the big one, could I say that my fraction, would this be 1/3 of what would fill into the big one, to the full prism? So the pyramid is 1/3 of the volume of the pyramid, because it takes 3 of these. That's the ratio you need to memorize and know, that the volume of a pyramid is 1/3 the volume of the prism. What fraction is it, class? Get ready? 1/3. 1/3. All right. So that is the ratio to remember. It takes 3 pyramids to fill up a rectangular prism with the same size of base. So it's 1/3 the area of the base times the height. So whatever the base is, it could be a triangle, it could be a rectangle, it could be a square. If you find that area times by the height, you've got the whole shape. But the pyramid takes up 1/3 of it. So you're going to take 1/3 area of the base times height. What's my formula? Get ready? 1/3 area of the base times height. 1/3 area of the base times height. Put that in your notes and look up at me when you're done, so I just know you've got it in your notes. Aaron's ready. Lucas is ready. Bethany is ready. Stacia, Spencer, Alex, Dakota. All right. Okay, find the volume of this square pyramid. So here's an example problem. This is example 2 in your book. We're going to do another one, a practice one like this. The area of the base is going to be 90 times 90, but let's first start with our formula. Area of the base times height. 1/3. Area of the base is 90 times 90. My height is 50, so I just need to find 1/3 of all of that. So 1/3 of 90 times 90, 9 times 9 is 81. I have 2 zeros, times 50. I'd like to get rid of the 3 first before making that number really big. So 3 will go into 81 how many times? Spencer?
It would go in 27.
27 times, nice job. So we've got 100 times 50. 5 times 27, the 5 times 7 is going to be 35. Carry the 3, 5 times 2 is 10, plus 3 is 13. I got 2 zeros. Wait, I have another 0. So my answer is 135,000 cubic centimeters. Now let me ask you this. If I told you to shrink down the pyramid and make it 1/10 the size, it's a little baby pyramid. Okay? And so now it's 1/10 the size. I would take 1/10 of 90, so it'd be 9 by 9 by 5 on the height. Could you figure out that volume? You're going to do that in the practice set, so just giving you a little sneak peek. And you're going to compare that volume to this volume. You're going to find out what fraction this is of that. All right, so sneak peek. Here we go. Next one. What if my base is not square, but it's a triangular base? And what if they tell you what the area is? So if this is my triangular base, let's use black. Where's my blue? I lost my blue. Volume equals 1/3 area of the base times height. What's my formula? Get ready?
Volume equals 1/3
area of the base times height. Area of the base, did they tell it to us? The area of the base is 36 times root 3. My height is 10, so from here to here is 10. So I multiply it out. What do I do with that root 3? Nothing. Leave it there. Just leave it root 3. So I'm going to go 1/3 of 36. That's going to be 12. That's not really a big contrast there. 12 times root 3 times 10. Let's throw the 10 in front. That gives us 120 root 3. And we leave it there. Throw our units. We're in units. Our units are units. And there I go. 120 root 3 cubic units. Any questions? Okay, last example. We didn't do a demonstration for cones and cylinders, but I wanted to just make sure that you understand. So here's our cone and our cylinder. They have the same exact area of the base. Look at the height. Are they the same height? Is the tip of the cone match up to the top of the cylinder?
Yes.
Okay, so the same exact. dimensions on the bottom and on the height. It would take 3 of these cones to fill up one of these cylinders. So it's the same ratio. It doesn't matter what the size of the base is. It could be a hexagonal, it could be a hexagon, it could be a pentagon, it could be a circle. It's still 1/3. But now we use a slightly different formula because the area of the base is round. We use pi r squared. What do we use? Get ready?
Pi r squared.
Pi r squared. So we're going to do one of those. Take.
What about like a cone and a cube, or like a pyramid and a
Ooh, there isn't a set relationship for those or a pattern. But we could probably figure out some type of, there might be something we could figure out, but it's not an easy one like 1/3. Okay, so let's do this example. Aiden built 2 cones out of sand on the beach. The diameter of the smaller one is 6, and the bigger one, and the height is 5. Then he makes a much bigger one. This guy's 12. Its height is 10. How many inches of sand, how many cubic inches did he use for each cone? So we're looking for the volume of the small cone and the volume of the large cone. Well, I need area, 1/3 area of the base times height. What's my formula? Get ready?
1/3 area of the base times height.
1/3 area of the base times height. I'm going to copy that down on both. So before I start, I write my formula. Just like on the RISE test, I want you to write your formula. We're going to go 1/3 area of the base is pi r squared times height. What is my radius in this example? Think. What's my radius? AJ? 3. Very good. So you're going to write pi times 3 squared, and my height is 5. So we're going to calculate that out. 1/3 pi times 9 times 5. I can take my 3 and 9 goes in 3 times. So I've got pi times 3 times 5, or 15 pi. We're in inches cubed. So that's my small area, volume of small. What about my large one? 1/3 pi r squared times the big H. What's my radius in this one? Dakota? 6. Right there. So let's put this one in. Pi times 6 squared times my height is 10. Let's calculate that out. Pi times 36. See where I got my 36? Okay. So then I go 1/3 of 36. Let's just do that now. 1/3 of 36 is 12. So I have pi times 12 times 10. 12 times 10 is 120 times pi inches cubed. That's my volume of this, the larger guy. Okay, question. How do these compare? 15 pi, 120 pi. This is like way bigger. But I thought all I did up here was, I did it times by 2 on the dimensions. See, I did 6 and I doubled the dimension. But wait, and the volume is that many times bigger? How much bigger is it, Lucas?
Because you also doubled the height.
I doubled the height as well.
So I need 4 times.
15 times what is 120? Hiram?
Well, I don't know like the whatever and stuff, but it's twice as big, and like probably has to do with the 1/3, but it's 6 times big.
We're close. It has to do with something. I'll show you in a second so you can figure out what's the ratio here. Take.
it's times 8.
It's times 8.
Oh.
So 15 times 8 is your 120. The volume is 8 times bigger. Why? This is a sneak peek of a future lesson. If the dimensions are twice as big, that's your scale factor, and we're in 3 dimensions, volume is cubed, right? Cubed. What?
Wait.
No way! I'm going to write that down, okay? Because we have a whole lesson on this, so don't worry about it. It's coming up. That's a little sneak peek for you. Kind of exciting. Okay, we're in 577. Take a 20 second stand up break.